Welcome to the session about filling the gap between data warehouses or databases in general and advanced analytics. We are going to talk about our services there is a lot of cool stuff in SQL Server 2016, as you know already, but our services are one of the best, in my opinion, and I have an hour to convince you that this one is probably the most important new feature. So I'm Marcin Szeliga, I'm from Poland, and I've been working with SQL Server for about 20 years already, but more recently I switched from SQL Server to data, actually. SQL Server is just a tool. Working with data is a lot, I believe it's more fun and more useful. So 20 years is a lot, so I managed to write a couple books about SQL Server. All of them are in Polish, so probably not very useful. The last one was about data mining, actually. Okay, I'm also SQL Server, so data platform MVP, and I'm the oldest MVP in this category in Poland. So enough. Yeah, the first one. It sounds better. Thank you. So the important part is that my email address is also here. So if you have any question about SQL Server, data mining, machine learning, our services, please drop me an email. I will answer for sure. And with this, let's go to the agenda. Just 3 points, and I'm trying to divide the time equally. First, I'm going to convince you, those of you who don't know R already, that it's the very last time to start working with R for different reasons. As you can see, R is the most popular data science tool in 2015 and 2016 as well. Then there is Python, SQL, Excel. There is no SQL Server Analysis Services or Azure Machine Learning here in top 10. The market share of those two tools is far lower, okay? But that's not a problem from Microsoft perspective. And that's the topic of this session, okay? So amazing R, the first thing. Then I'm going to show you the basic R integration with SQL Server. With this only, you will be able to reuse all your R libraries in more efficient way. And finally, I'm going to explain the full R Microsoft product suite and show you how to use them to solve business problems. Because for each of those 3 parts, there is a presentation. There is just few slides and then a goal, a problem to solve. And we are going to solve those 3 problems using R. Hopefully, you will find this useful. So, R is growing. And what's this R, first of all? So it's a language, but it's not a general purpose language. R is right here. Yeah? So the Java, C, C++, Python, C#, and R. The highest rank for non-general purpose language right now. The only language that rose through this ranking from 2015 to 2016. So R is definitely growing. There is more than 3 million people using this language daily. For what? For data transformation, analysis, not only including machine learning algorithms, and data visualization. But R is not just a language. The community is actually quite important because you are going to start using R, you will find a lot of online resources and help. So you will be able to solve almost any problem with the support of this community. That's a good thing. But the most important part is that R is also an ecosystem. There is a comprehensive R archive network website, this one. it looks like this, by the way. It's not this pretty one, it's this one. And right now, there is more than 9,000 packages, let's say libraries, available here, developed by pretty smart people, including people from different universities around the world. So here, you will be able to find a dedicated library to solve very specific problems with data. Okay? Let me show you an example, because pretty common, oops, sorry. Okay, I'm back for a moment. Pretty common problem is to impute missing data. I suppose that you have to deal with this problem this way or another. And with R, it will be rather easy. So let's start with searching through those packages. And I happen to know that the name of this library is Amelia, a program for missing data. It's like this. And here, we will find an information and documentation about Amelia, like here. And now it's the worst part of this session, because it will be easy to use this Amelia library. You will see this shortly. But you will spend some time trying to understand the algorithm behind, so how it works, how to tune it, okay? But we are talking about R, not about mathematics right now. Okay, so there is a help. Why is R so popular? R is the next version, let's say, of S language. S stands for statistics, and R is far more popular than S ever was, for two simple reasons. First, it's free. Okay? This comprehensive research archive network, all those packages, all those libraries are free. You can use them for free. Then there is a lot of people not only using but also contributing, as I said. This Amelia was a simple example. Okay? So it sounds like a best tool to solve some problems. You don't have to wait for a, let's say, Microsoft to release the version 1.2 of their product to get new stuff. It's open source community. No new libraries are being uploaded to this comprehensive R archive network daily. And just one tip, because it will be easier to follow those examples, to know that R is polymorphic, which means that the same function, the same command, will return completely different results but depends on the type of parameters. A plot function is a good example. If you pass some numbers, you will get just points. That's it. If you pass a regression model to the same plot function, you will get some fancy visualization of this model. Okay? So it's probably quite easy to learn this R. So with this, as I said, we have only 60 minutes. First task, first problem to be solved. So let's suppose that our customer is a water company, and we got the data collected from pump stations daily. And there are 4 questions we're supposed to answer. First, let's say that's even not a question, that's a problem. There are some missing data. For whatever reason, human error or something happened, and not all data was collected. We have to replace those missing values in the best possible way. Otherwise, we will not be able to answer those additional questions. So, first task, complete missing data. Then, there is not only data about total volume pumped by those stations, but also rain level and underground water level. And business would like to know if there is some kind, if those data are some kind correlated. It will help manage those pump stations probably. So we are solving real problems. Then maybe there are something unusual values in those data. Unusual, that might be a leak. It's pretty important to detect a leak in a network, water network, as soon as possible. Or a fraudulent customer, I have no idea. Something unusual. Finally, time series means predictions, yeah? Let's say that it would be nice to be able to predict the pumped volumes for the next week or two. With R, it's easy. So I'm using right now RStudio, also free tool, available to download. And already, I loaded already some libraries. It's not that important. Can you see, by the way, this code clearly enough? Hopefully. So in my case, the data is stored in SQL Server. What a coincidence. So I'm going to execute a simple select statement to load, to fetch the data. It's like this. The date, total value pumped, this pumping station, that pumping station, rain level, and underground water level. There are also two additional variables. This 5 days moving sum of rain level. I'm going to explain this later. And daily difference in underground water level. I compute those based on this, of course, yeah? So that's our data. What we can do with this, with R. First, I'm going to convert this to time series data. It's TS function, that's it. Starting point and frequency of the observation. This part is a technical part. I'm going to extract some values to variables just to simplify the code. And finally, let me plot this. I need to have this window a little bit bigger for this. Yeah, so that's our data. What we can do with this? First, missing value, if you remember. So probably it will be easier to spot those missing values on this plot. Yeah? So underground water level, here is our problem. For about a month, that there is no data. How to impute, how to replace those missing values. Those missing values, by the way, because it's easy to zoom in or zoom out using R, as you can see. Yeah? If you please try to remember the shape of this line here. So let's start with naive approach. We can use approximation or interpolation. Why not? It's also the matter of execution of specific R function. But we got something like this. Can you see the problem with this naive solution? This doesn't look like this at all, yeah? So which one is better? Or left? Who knows? Luckily, we spent some time searching through comprehensive R archive network, found this Amelia package, yeah? And then spent some time analyzing this algorithm, actually. And we know that Amelia will do something more. Will take the seasonality and trend into account. That's the first thing. And then it will look for correlation between variables. And I'm also going to explain this concept later. But now, we are just going to execute a function, yeah? So let's check those missing values. Yeah, the underground water level is the only missing, it's the only variables with missing values, so we are good with this cross-correlation concept. Nice. Okay, so maybe it should be like this. There are some points, yeah, imputed by this Amelia function, and the confidence level added to this. So you were right, actually, this shape is more natural for this time series. Yep. And of course, we should also provide some proofs. So let's do this. Here, we can compare the residuals, so errors, against observed values using the same Amelia library. And we can see that for lower values, we tend to predict or impute slightly higher values. So it's an error, yeah, residual. And in this area, so for higher underground water levels, we tend to predict or impute slightly smaller values. But overall, the performance is not so bad. So with this, I'm happy. I'm going to add those missing values to the original variables and continue. The second question was, check the correlation between variables. And yeah, why not? We can use person, yeah, correlation coefficient. Why not? It looks like this. It's not probably the best way of presenting results. So maybe this one is slightly better. Just one line of code, yeah? And with this, I got that pumping station 3, pumping station 4, they are correlated. That's the 81% of variability in this series can be explained by this data. Yeah? You can check this matrix like this. And the rain, unfortunately, is not correlated. Below 30% is statistically insignificant correlation. But if I aggregate this data, yeah, 5 days rain, moving sum, now I got something. So by adding or preparing data, I can improve this kind of analysis a lot. But not always. Here is the underground water level. It's correlated already with both those values. What about daily difference? I lost this information completely. So this part, yeah, enhancing data, is the toughest and probably the most important part of advanced analytics, not just applying some algorithms, okay? Good. So with this, we can start talking about autocorrelations. Autocorrelations is the correlation of variable with itself at different points in time. So t minus 0 and t, so of course it must be 1. It's a yesterday data, the day before yesterday, and so on and so forth. Looks like this kind of data, this data is strongly autocorrelated. That's good, because it means that we will be able to predict future values based on history only. That's ARIMA models. Yeah? Okay. And what about cross-correlation in time? Now you know the concept of correlation, autocorrelation, and cross-correlation is combination of those two. Yeah? I'm checking the total value pumped, correlation between total value pumped and underground water level today, yesterday, the day before yesterday, and so on and so forth. And I got also those nice shapes and correlation coefficients here. Has a lot of information, probably useful data, and just like 10 lines of code so far. Okay, then detect outliers, the third task. And for this, there is anomaly detection library handy. And maybe you spot that this part here, the data looks unusual, even by spotting. Yeah? And the algorithm confirmed this. Something was wrong here. And for whatever reason, here as well. Unusual. The predicted and actual values are different, significantly different. What does it mean? I have no idea, but subject matter experts probably should check those dates. And not only this, but I can also find change points. Change point can be useful because it means that the data change significantly in terms of standard deviation and mean values at that time. So something happened here in long term. Okay? Almost done. The very last task was to predict something, yeah? So one more time, autocorrelation. Autocorrelation coefficient can be measured, of course, and visualized as well. As you can see, those are marks. Above those marks, there's statistically significant correlation. So we confirm this fact. We know already. So let's go and build a ARIMA model. And probably you know that there are 3 parameters that must be specified for ARIMA. Yeah? But we are working with R, so it should be easy. So there is auto-ARIMA function. So let's find the best combination of those 3 parameters automatically. Yeah? Like this. Okay, I have my model. I can forecast a future. Let's say 2 weeks. Yeah? And that's predicted values. Yeah, but it's boring. So let's plot those predicted values. Slightly better, yeah? Okay? And always deliver some explanations or proofs so we can, okay, yeah, that's the problem with RStudio and the low resolution. Let's try to fix this. Okay. So, you know that residuals means errors, difference between the actual observed and predicted values. That's the residuals over time. Most of the time they are quite okay. There are some spikes, unfortunately. And here is the autocorrelation of residuals. So if you remember, the original data, this autocorrelation was way above those blue lines. Here, most of the time, except here, yeah, we have some spikes, which means that we explain all the variability with this ARIMA model, and there is no way to build a better model. AutoARIMA did its job correctly, okay? Nice. So, as I said, short introduction to R. But, let me move to the main topic of this session right now. So R, I hope you find R useful to deal with business problems easily. But there are some limitations. And let's start talking about Microsoft R Open and Microsoft SQL Server R services. There's a lot of information on this slide. The important part right now is just this. Starting with SQL Server 2016, any edition, we are able to execute R scripts on the database side. Not locally with RStudio, but by SQL Server. Okay? So there's the very basic level of integration. And by the way, that's the new icon, yeah? Microsoft, it's also new name, Microsoft R Open, and all those names will be explained at the end of this part of presentation. So we have SQL Server R services, and all you have to do to use them is to install SQL Server 2016 with R services, and that's it. Yeah? So click, click, click next, you're done. There are two options, and I'm going to talk about this the first one, in database, which means that there will be additional service, trusted launchpad service, that will be used by SQL Server to execute external scripts. Right now, only one language is supported, R. Okay? This standalone Microsoft R Server means that you are a data scientist, you don't have to have a SQL Server installed locally, but still you would like to execute some R scripts. Yeah? So with this, administrator, SQL Server administrator, have to set this external scripts enable server level settings to true, and that's it. Then there is just security. Okay? We are adding some permissions to our users. End of story. What are the advantages of this simple integration? First, and we are not going to move the data from SQL Server to compute, to perform some analysis locally and see the results. Instead, it's a, let's say, MapReduce approach. Move the computation where data is. Yeah? So data is stored probably in SQL Server, and the computation also will be performed on SQL Server side, and only the result will be sent to the clients. That's it. How to achieve this simple goal? We got this sp underscore execute underscore external underscore script store procedure. And there are 4 parameters. The first one is the name of the language. The only supported option right now is R. The second parameter is the R script by itself. The third, input data, probably the result of some select statements. And the last one, the results of the script. So the script probably, returns some data. It can be a data frame, let's say table, or even a binary data, let's say a plot. Sounds easy, isn't it? So, the second task. Now, we are working for a company, and the CEO asks us if we are able to check if some vendors are fraudulent, maybe. All we got are transactions. Okay? So, we are starting with something like this. Let me show you. Here. There is more data, actually. Okay, so vendor, invoice number, and actually that's it. Nothing more. 245,000 something rows, yeah? What can we do with this? How to solve this problem? Fortunately, we know Benford law, don't we? Okay, so it started in 1881 when an astronomer, Newcomb, noticed that in logarithm tables, the first pages that start with 1 are much more worn, means they are more frequently being used than other pages. And this observation was confirmed about 50 years later by Frank Benford, who checked data coming from very different sources. City populations, death rates, invoice numbers, river lengths, whatever. And confirmed that the first or leading digit in all those data sets is probably 1 in 30% of cases, and rather not 7, because 1 is more than 6 times more frequent as a leading digit than 7. Okay? So 1, 2, 3, 4, 5, stuff like this. Sounds interesting, yeah? And actually, in 1992, the Benford law was used to put under jail the chief accountant of Arizona State Texas accountant. Okay? So it turned out that this guy signed his own checks for almost $2 million. They were paid, of course. Yeah, it was chief accountant. But unfortunately for him, he didn't know Benford law. Okay? And the frequency of the leading numbers in those checks, yeah, was unusual. So let's do this time using our services. So I'm changing the platform, yeah? So I'm changing the tool, that's Visual Studio, with R tools already installed. Yep. R tools are free at in, but you have to have a full Visual Studio. SSDT is not enough to install R tools. You can use free community edition, but you still have to have Visual Studio 2015 installed. And with this, let me check. Yeah, actually I'm using Microsoft RSava, not this ROpen. And the idea is still the same. Let's find useful library and use them efficiently. Again, data is stored in SQL Server. So I'm going to connect to the SQL Server and execute this select statement. And I got something like this. I'm going to use Benford law. So I count how frequent some digits appears for different vendors, yeah, as a leading digit. That's it. But the format of this data, it's not the best. I'm a database person, so I would like to pivot it, yeah? And there is, as always, a specific function in R, in this case dcast. So with dcast, I got this. Now we are ready to go, yeah? Great. So let me apply Benford law. It's here to this data, and name columns. That's it. Output data sets. There are just 8 rows because I remove those vendors that are probably okay. Yeah? So it's just 8 suspiciously looking vendors. Nice. But still, I would like to present the result in more appealing way. So I need a plot, yeah? I need something like this. Now it's clear for everybody, for the chief of this company, that this vendor, it was a specific vendor. Yeah, sorry for the resolution. Again, this, where is it? Ah, here. That this vendor overused the number 2 a lot, yeah? Okay, but it's R, but inside Visual Studio. So now we are going to move this to SQL Server. All we have to do is to start using good old Transact SQL. copy and paste. Great. So let's start with preparing the environment. It will be like this. OK, that's just to get the base data, nothing fancy, nothing special. OK, again, to be sure that everything is in place. Now I'm counting the frequency of leading digits using this function, this procedure. Also nothing new. Now something new, yeah? I'm going to execute external script, and that's copy-paste, the script you already saw. OK? Shit. Nice. And the second one to generate some plots. That's it. With this, I can do some improvements. Let's say I would like to get all those plots by calling single store procedure. It's just the optimization. And now it looks like this. Let me execute the store procedure and insert the result into fraudulent vendors table. I'm expecting 8 rows. Yeah, that's the case. And let's say if I can generate a plot. Yeah, I can. Looks the same? Not really? OK, so let me generate all those plots. But I'm using SQL Server. Maybe there is a tool or a service with SQL Server that can do something with this binary data. Maybe SQL Server reporting services. OK? So, yeah, we got all those 8 plots. So I'm going back here, and there is the very last part of this demonstration. SQL Server Reporting Services project. And there is a simple report. The data set for this report looks like this. So nothing new. You already saw this data, yeah? But by using this binary data in SQL Server Reporting Services, it's just saying that in this column, the plot will be generated based on specific column, yeah? Image properties, yeah, that's my column, yeah? OK? I have, hopefully, the final solution. Yep. "10 minutes and problem solved." On SQL Server side this time. But still, it's not good enough. So to show you the true power of SQL Server R services, we have to mention a company named Revolution Analytics. Revolution Analytics, it was a big player in this R ecosystem. The most famous for this, it's Revolution R Enterprise Server and the Revolution R Open. So their own implementation or version of R Open. And RevoScale library. OK? RevoScale R, the OpenR, you probably cannot use OpenR to analyze big data. First, it's memory-based, which means that you have to have enough memory to load all this data set into memory and do some computations also in the same memory, using the same memory. And some algorithms are really memory hungry. To analyze a gigabyte of data, you will have like 500 gigabytes of available RAM. Yeah? So sooner or later, you will hit the wall with OpenR. RevoScale library deals with this problem. you will find some documentation here, how they achieve the scalability and so huge performance improvements. And here, there is also a Microsoft version of this documentation, but we are not going to I'm not going to say it right now. It should come as a surprise in 2 slides. And there is information what was already implemented in this RevoScale library. Because on CRAN, there is 9,000 packages, like 20-something thousand functions. Yeah? In RevoScale R, there is only about 500 functions already implemented. So it's huge difference. OK, so I'm not going into details. RevoScales gives you data chunking, so you can persist the result of single computation or data transformation, the result of single step on hard drive using this HDF format. It's a memory dump, actually. So it's blazing fast. And you can search by row or by columns through these XDF files. So it's even faster. And the second problem with OpenR is that OpenR is single-threaded. So it doesn't matter how big your computer, your machine is. OK? With RevoScale, it's different story. RevoScale is written in C++, so low-level library, unusual thing for our ecosystem, actually, in a way that all computations are automatically threaded. OK? And this algorithm is actually pretty smart. So the last thing I would like to mention about the RevoScale, very important one, is that it allows you to change compute contexts. You can think about that OpenR, the compute context for OpenR is always local single-threaded. But now you have different options available. You can say compute context local parallel. Even better, you can say compute context Hadoop cluster or SQL Server. And now we know all the story. So the point is that there is no Revolution Analytics any longer. Yeah? The company was acquired by Microsoft a year ago. All those smart people working for Revolution Analytics now works for Microsoft, improving and developing RevoScale library mostly. OK? So it's not, by the way, it's not RevoScale, it's Scale right now. The name also changed. And with this, we got Microsoft R Open, so the free open version of R, implemented and enhanced by Microsoft. And you will see the difference easily. You will spot the difference easily by looking here. That's the Microsoft R Application Network website. Yeah? It's like CRAN. They are actually taking CRAN snapshots since 2014. So you can go back in time here. You will find a version of specific library from the past here. Can be quite useful, believe me. And of course, here there are also a way to find a package or a library. And you already know that there should be Amelia. So let's try. Yeah, that's the same, yeah? OK? Microsoft R Open. Free open source R distribution. And Microsoft R Server, the last part. Before Microsoft R Server, let me summarize Microsoft R Open. So first, there is this website. You already saw it. There is some improvement taken from RevoScale and added for free to Microsoft R Open, like checkpoints and mini-CRAN. Mini-CRAN can be quite useful if your server is not able to connect to CRAN or Microsoft version of CRAN to download and install some packages. Yeah? It's like a proxy server, local proxy. You will be able to parallelize some computations for each. It's not as efficient like level scale, but still something. And you can connect and work with Hadoop or Azure Machine Learning. This is pretty cool. You can develop the whole model in R and then deploy it to Microsoft Azure as a Microsoft Azure Learning Web Service with single call. So, Microsoft R Server, yeah? The last part. We have like 15 minutes, including Q&A. Good. So, what we got? Microsoft R Server means Microsoft R Open part plus Microsoft R Server, that's the Enterprise Edition feature. Not free, paid one. And the most important part of this Microsoft R Server is Scale R, formerly Revo Scale R library. Okay? Good. And there is also a tool to deploy R easily, a tool to connect R to different data sources, and a framework to scale out those R services. Quick comparison, OpenR, Microsoft OpenR, and Microsoft R Server. The first two are supported by community. The last one got the commercial support. It's also quite important for some customers. I had this discussion previously, why we are not going to start using R, because first of all, it's open sources, and it's not server-based. So we are not going to invest a lot of money and future of this project with this, yeah? We risk that something sooner or later will go wrong. Here, no worries. Okay, so the last demonstration, the final one. Now, let's suppose that we have a friend, and he is a taxi driver, or she is a taxi driver, and ask us, can we, as a data scientists or data analytics professionals, this way or another, help her to choose the right call? As a taxi driver, she would like to only took a tour or a ride when we got a tip, when we got tipped, okay? And she provides us with the data from her company, the past data about history. It's New York City, the starting location, the length of the trip, the number of passengers, stuff like this. Also with the information, got the taxi driver a tip or not? And with this, we are going to build a prediction model. Yep. Okay. So, I'm not touching anything. Here. So first, we need to prepare some data, yeah? So I'm going to load RevoScale R library. And I managed to load this library into memory successfully, which means that I'm using R Server, not R Open or Microsoft R Open. There is no RevoScale R on CRAN, okay? And then let's connect to SQL Server, nothing new, nothing fancy, and set compute contexts to my SQL Server. And we also need this share. If this trusted service would like to exchange some data with SQL Server engine, it's not always about rows and columns, yeah? There can be pictures, XML data, whatever. The output will be temporarily stored here. So it's an exchange place. Okay, so let me change this compute context, and now let's check what's going on. So first, I'm going to select some data. Nothing was sent to my local machine. Still, the compute context is SQL Server. I can, however, do something with this data. Change the metadata, yeah? Type of column, whatever. Doesn't matter. Still, SQL Server only. Now I'm going to execute a function. So there is Rx means revo scale version of something. Get var info. Now, yeah, the result will be sent to me. The same with this, Rx summary. So the revo scale version of summary. Let's check the fair amount divided by passenger count, yeah, into 6 bins. Okay, so yeah, it's like this, yeah. If there is single passenger, the mean is 10. If there is 6 passenger, the mean is slightly higher, yeah. Okay, of course, we can also use visualizations, Rx histogram. Sooner or later, we will see the distribution of fair amount. Yeah. Most often it's 6, maybe 8, but sometimes you can get as high as 76. Yeah. As much as 76. Okay, important part. You should wisely choose SQL Server, so transact SQL, or R, depends on the performance mostly. There are some kind of calculations that will be way faster on SQL Server performed by transact SQL, like calculate the distance. So I'm going to mix those two techniques here. And still, of course, I can work with this data as previously. Okay. Now, I got my data. Now I can build a model, yeah? Probably. So, there is Rx logit function, means logistic regression in revo scale R implementation. And I'm going to check the time, how long it takes to train this model. I'm predicting tipped, yes or no, the probability actually, based on passenger count, trip distance, trip time, direct distance, yeah? Oh, something is going on. Yeah, it was, in my opinion, blazing fast, actually, yeah? And there is a slide that will show you the difference. So it's, yeah, of course, the logistic regression model already in place. And now I am going to use this, yeah? I'm going to use this to predict the score, the probability, and the result will be sent back to this table, to SQL Server. So those two commands have to be executed simultaneously. Okay, there is data already there, and I can, as always, check the quality of this model. Yeah, it's hard to see here, but it's slightly better than random guessing. Doesn't matter in this case. Okay, so how to use this? I'm going to serialize this model and send this serialized model to SQL Server and store it in the table. So there is a single store procedure. persist model. Let me show you the code for this. Actually, I have it here probably. Yeah, it's just this store procedure. Yeah, it's just insert into serialized value. Yeah, that's it. And use it. Yeah, finally. So there is another store procedure. With this store procedure, yeah, the result is 49%. The chance that I got tipped with this strip, this one, is 49%. Yeah? And this store procedure works like this. Let me show you. Here, predict single trip. So that's my source data. Yeah? And that's the important part. I'm going to unserialize this model and then use RxPredict function with this model and that data. That's it. Simple engineering stuff. Sure, and I can also use not just a single row, but a lot of rows. So the result of the select statement as a source data. And finally, we will see some results. Yeah, this looks promising. Yeah, 68%. This is probably, I'm not going to answer this call. OK. Important part here to remember is that Microsoft R Server really scales a lot for two reasons. First, through parallelism. That's the OpenR scalability. That's Microsoft R Server scalability. And even more important factor, because of data movement, changing this compute context. So you can see the results like this one, from hours to seconds, or from days to minutes. It's pretty common, actually, to see this kind of performance improvement. So, summary. R has its momentum right now. People who knows R are they are needed a lot, especially in US right now. You will get a lot of money if you know R and statistics. So maybe it's an opportunity to start working with R. It's not that hard. And now, with R services, you can put the result into production easily. Yeah? That's the difference. And it scales. So you can apply R to big data problems as well. It's really something new. And the final message is that R integration is not just ability to execute R scripts by SQL Server. It's much more. OK? OK. It's only 2 minutes for questions and answers. But if you have some, I will try to answer them directly. But probably you are going to win some prizes and spend some time during barbecue. I will be also here and will be more than happy to answer all those questions later on. OK? OK, so with this, thank you very much.